Good day, mathletes, and welcome to a conversation about transformations in function notation. When we first learn about transformations in any type of function, we often learn about quadratics or parabolas that are maybe moving 2 units to the right and 3 units up. And we talk about this transformation notation in this xy form. Now, we can introduce function notation and say this parabola now has a name, and this name is f of x. And we're now in function notation, but not necessarily talking about transformations in function notation necessarily. What we start to see as we introduce this new type of language and notation is to say, here is a quadratic named f of x. And this is going to be our base parabola, y equals x squared. But its name is f of x. I can then say later with another statement, all these y values separately, there's a graph that's going to be drawn and all the y values are based on the graph of f of x. So these would draw the same thing. The first one is saying we're going to draw y equals x squared and the name is f of x. The one on the right is saying we're going to draw a graph, all the y values are based on f of x. Alternatively though, I can use this right example to say, okay, I'm going to draw a graph y equals f of x, but I'm going to actually move everything up 3. So now what we're actually doing is we're starting to see a graph being drawn referencing a function f of x, and then we're going to move it up 3. Now, you would see the same shape, but something's happening to it. I could, though, stretch this by a factor of 5, and on this input here, I could say I'm also going to move this 1 unit to the right. Now you might look at this and say, what is this going to look like? Well, it's going to take this x squared graph, stretch it by a factor of 5, shift it 1 to the right and 3 units up, but you don't see any x squareds in here. That x squared notation doesn't show up in this circled part here. The x squared portion of this is being referenced in the function f of x. So it's this f of x notation that is how we're kind of connecting this to what the graph looks like. If I erase this part on the left and I said, sketch me what's in this circle, there is nothing that you could draw because there is no f of x that we're referencing. Let's actually play with this in a visual form and kind of understand and see what this is like. Now, we can say y equals x squared and see our parabola show up as we normally would. I could say, well, I'd like to graph something where there's in function notation f of x plus 3 like we saw before, but it doesn't actually understand what to graph because it doesn't know what f of x is. But the second that I change the name of this original function to say y equals f of x, it can now graph the original red function. And we can draw it shifting up 3. And that's the blue one. So what we're actually doing is we're saying, and I'll get rid of the original function again, I'm going to say something is being drawn shifted 3 units up. I can again say we're going to shift it 1 unit to the right, and we see that move. And I can stretch this vertically by a factor of 5, and it looks again quite narrow. Now, I don't have to force this to always be a parabola. I can alternatively say, well, let's make this the square root of x. And what you're actually going to see in this scenario, and I'll get rid of all these transformations that are happening here, at least some of them, and you can actually see there is a radical function now, f of x, a radical function that is moving 1 to the right and 3 units up. I could, instead of saying this is a quadratic or a radical, I can say this is the absolute value of x. And now we're seeing the name still f of x be a different function and still having the same 1 to the right, 3 units up transformation being applied to it. So in this blue graph, in this y equals f of x minus 1 plus 3, I'm not seeing the connection to an absolute value or a radical or a quadratic in its one line. It's using the f of x to reference it. And so as we consider what function notation transformations are, you don't have to have an x squared in both lines for it to draw a quadratic, you just need to reference the function f, and that will sketch what you need to.